So we're going to go through standard and vertex form using different methods. So standard to vertex form. A very, very common method is called completing the square. I'll just draw a square. Okay, so completing the square. I'll walk you through that, and I'll show you two formulas after that you can use to do the exact same thing. And it's up to you whether you rather memorize the process or the two formulas. Usually the very first step to this is to divide the very first two terms by your a value. So because our a value here, okay, this is in standard form, ax squared plus bx plus c, okay, the a value is the 3, so we're going to divide the first and second term by 3. We're going to common factor it out is really what we're doing here, okay. So f at x is equal to 3 becomes our common factor, and within those brackets we have x squared minus 8x, okay, and then again plus 50. The next step is to use a little formula on the side. They usually refer to it as b divided by 2 squared. But it's not the original b. Okay? They're actually looking at the new b, the b that has the 3 or the a value factored out. Okay? So this new value, negative 8, is what we're going to plug in here. So we'll kind of do it as a side calculation. Negative 8 divided by 2 squared. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So 16, we're actually going to add and subtract 16 within these brackets. Because if we add and subtract, it's like adding zeros, so we haven't actually changed our function at all. So f at x is equal to 3x squared minus 8x plus 16, subtract 16 plus 50. Okay. The next step is to keep the negative version, okay, or sorry, the positive version, the positive 16 within the brackets, and to take the negative 16 outside. In order to do this, we have to actually use some distributive property. Because this 3 is here, we need to multiply this by that a value. So we have to multiply negative 16 by 3 when we bring it up. So the next line would usually read 3x squared minus 8x plus 16 stays. Okay. And negative 16 times 3, I think is going to be negative 48. Okay, and I'll do that in a different color here. Double check that for me if you like. And then plus our 50. Okay, while you double check, I'll do the math on the outside. Was it correct?
Yeah.
Beautiful. Okay. When we add the two numbers on the outside together, we're going to get positive 2. Okay. So the reason we've done this is we've made a perfect square trinomial. And a perfect square trinomial is something that is talked about very often, but really all you need to know is that you can square root the first and the last term, and whatever the operation is of the middle term, so that negative sign, we bring that down. So if you recall your vertex form of something, okay, we have 3. Square root of x squared is x. Square root of 16 is 4. The term in the middle is a negative. And our vertex form, we take those values, we just square them both, and we have our plus 2. And this is the vertex form of it. So again, you could go through your factoring where you take a times c, okay, and then we need to find two numbers that equal 16, and then they add to our negative 8, and you can go through that whole decomposition process. But what you've built is something where you can use a very fast style of factoring. You can square root the first and the last, and those are going to be the first and the second term in that bracket that's squared, and just bring down the negative. And that is our vertex form. I went through it very quickly. There's usually a couple more steps, but if you're familiar with it, you're okay. Another way we could do this, okay, and because I want to show you what the vertex form is normally written as, it's normally this is your a value, okay, x minus h is the letter they usually refer to, and then plus k on the outside. Does that seem familiar to you? Okay. Now, there is a way from standard form, without doing this process, we can use two little formulas. H, or the x value of the vertex, they're technically the same thing. Okay. So we'll say is equal to, okay, is equal to negative b divided by 2a. Okay. And that's referring to the b and the a in the normal standard form. The k value, or the y value of the vertex, is equal to this little formula, c minus b squared divided by 4a. And all of this is kind of in its own bracket. Okay, so I'm going to rewrite the original standard form we had above. I'm going to write it again. We've already completed the square. Let's see if we get the same answer. We know it's 3x, whoops, I'm writing in, let's write it in standard form. 3x squared minus 24x plus 50. Okay, so as long as we know that this is the a, so that's where we'd replace these a values, This is the B value. We place this B and this B. And this is the C value, which only really counts there. It's really just a plug and play. We put those numbers in, we carry out the formula, and we got those values. So let's kind of give it a try. Our negative B. So negative B, well, that's negative 24. So that ends up being positive 24. Okay. Is over 2a. Well, that's 2 times 3, which is 6. 24 divided by 6 is going to equal what value? Should be 4. 4. And that is our h value. So if I'm building our vertex form, y equals, I'm going to just put underlines here, a x minus h squared, and then plus, here's our k. This is our h value, our 4, so negative 4. If we look up here, that's exactly what we got, so it worked out really nicely. In our other formula, again, plug and play. So c is our 50, so is equal to 50 subtract. Our b value was negative 24, so this is where it's a little complicated. A calculator comes in handy. We have to square that value. And divided by 4 times a, so 4 times 3. Now let's do that squaring of 24. What does that become?
Negative 576.
Okay, it won't be negative because 2 negatives squared will be a positive, so it'll be positive 576. Divided by 4 times 3 is 12, so we need to divide 576 by 12.
48.
Minus 48. 50 minus 48 is the value of 2, and remember that was our k, so our k value is 2. Worked out great. The only thing we didn't get was our a, but our a value from standard to vertex is the exact same number, so it's 3. So either method works. The more common one shown is completing the square, but these two little formulas, if memorized, can take you there really, really quickly, especially if you're okay at using them.